All right, I got one more example just in case you want to see the process more than and I'll choose one from the second page here. This one's a tricky one, a little bit, not horrible. But let's try this, okay? First, aluminum. Let's write down the symbol for that. Chemically, it's Al. Potassium, you know what that is. Okay. Hydroxide ends in "ide." If it were possibly a single element, you'd be looking all over for it. But you got to remember, that's one of those polyatomic ions. So that's where memorizing that polyatomic ion list. Get that little 3x5 card out if you remember. Get those, written onto that 3x5 sheet. That'll help you remember hydroxide, so you're not spending all your time looking for, it's "ide" and it's not a single element. Hydroxide, cyanide are the two "ide" ones that are the most common that aren't a single element. Now I'm going to go to potassium again, and I have no clue what aluminate is. It's probably, I don't even think it's on the back, but I've given you a symbol for it. Okay, so that's going to be K3, ALO3, and you're going to have hydrogen left over there. All right, now let's balance each one. So the first thing was to get the elements down. The second thing is to put their little charges on. This one's +3, but it's not in a compound, so we don't even really need to write it. If it's not with a compound, it doesn't have any charge. It's just 0 charge. Potassium, on the other hand, is with something, so that's +1, and that's a -1. So that's happy. +1, -1. There's 3 potassiums here. So what do you suppose the charge is on an aluminate? It's got to be a 1. This has got to be -3. Okay, that's the way they came down like that. And then hydrogen, can it be alone? No, it's one of the diatomics. It has to have a 2. H2N2O, F, B, F, Br, Cl, and everything down that 7th column. So now I balance each one separately. Now I have to look from left to right to get them all to balance out. Aluminums. Okay, I've got 1 aluminum on the right, 1 aluminum on the left. That works out. Ooh, we got 3 potassiums though, so let's put 3 in here. That gives me 3 Ks. 3 Ks. It also gives me 3 Os, which actually works out for the oxygen. But hydrogen's a little tricky. I've got 2 over there, and now I've got 3 over there because this 3 is in the front, so I got to get to a common multiple. We're looking to get to 6. So if I put 3 on this side, I'm going to have to change this to twice as big. 6. Okay. Now I have 6 pluses. I got 6 H's, but I goofed up my potassium, so now I'm going to have to come over here and put 2 there. That goofs up my aluminum, so I'm going to have to come back and put an aluminum over here. I got 6 O's, 6 O's, 2 aluminums, 2 aluminums, 6 potassiums, 6 potassiums. The hydrogens all work out. Okay, so that's a nice kind of trick to do. If there were a polyatomic ion on both sides, then you count the whole one, but since it doesn't occur over on the right side, I had to go atom by atom. Okay? That sounds good. Good luck with your other ones.